Hi. So in this video we are going to install open source IC design tool called Xschem, and Xschem is let's look at the Xschem and a bunch of, let's say, open source analog IC design tools. So there's a website from SSCS and it tells you about basically open source IC design tools. This is not only analog IC design, I believe it's also including digital IC design. So Xschem is for schematic capture, and we are going to download PDK, which is called Sky130 nanometer. This is open PDK. We're going to install Ngspice for the simulation, and for the layout we are going to download Magic VLSI. So if we go to Xschem, if we search Xschem Sky130 PDK, so you go to this Xschem website. It basically tells us how to install Xschem, Magic VLSI, Ngspice, and finally install this PDK. After successfully installing this PDK, there's a example page and tells you how to simulate everything. I myself followed these instructions, and the journey is not that pleasant. It took me 2 days to install everything and then simulate a schematic. But here I'm going to show you a very shortcut to install everything. Basically, I summarized in my own way. So I'm going to I uploaded these 2 shell scripts on my GitHub, and I'm going to share the location on the description below. Okay. EDA tools download. We are going to there's a very easy way to download everything at once, but writing everything into like a script and then source this file to install everything, but sometimes we have a lot of error message. So I suggest you do step by step, and by doing this, first you are error free, second you are much more familiar with Linux system. So here, copy. Here is it's not Control V for the paste. Okay, so it's your mouse middle button. It will paste this one. Enter the password. And make a directory called EDA tools. So, and we are going to save every open source tools on this directory. The source files we are going to keep on this folder. So make sure that what is the current directory? Print print working directory. So we are in our home page. The code, the folder name, your username. Great. So from here, we're going to make a directory called EDA tools. So here, EDA tools created, and then we are going to download and install every tools inside this directory. We are going to separate the source files, and later on we are going to create a project directory, and then we're going to save every project in another folder. And then just copy paste this one. So this is the pre-requisite tools that we need to install first. Continue, yes. Without installing these pre-requisite tools, the installing scheme and the other tools will not be successful. So make sure we pre-install all the required tools. It's actually already stated here in the official website scheme. So if we go down here, installing Xschem. So when we configure the Xschem, it says for the Debian and the Ubuntu, make sure that these packages, these libraries are already installed. These packages you should check to be installed. And sometimes maybe these packages are not enough. So make sure that when you are downloading, when you're installing all the tools, make sure that you check the error messages. If there's any error messages, make sure that you debug it. I came across several uninstalled situation, so it's pretty easy to solve. Just Google it, whatever package that you are not installed in the system. First install it, and then you can successfully install the Xschem. So in the meantime, maybe I can quickly explain what we are doing here. After installing this pre-request, then we are going to install the Xschem. We're going to download the source file from the GitHub and then configure it and install it. After that, the same thing, we are going to download the Magic VLSI for the layout design. Again, download it from the GitHub. Okay, here we are finished. Okay, now we are going to install the Xschem. Make sure that we are in EDA tools. We are already there. So, and then this is the same as the official website. Download the Xschem from the GitHub here. Do that from EDA tools. Okay, we downloaded Xschem source file. Go to this source file and then configure it. Okay, let's see if there's any error. So configuration complete, ready to compile. So there's no error. And then make. Let's see if there's any error here. I think it's good. So the make, then install. All right. There's no error. I remember this is my second time installing. I remember when I first installed, there's some error, there's some packaging, some library is not installed. So I searched on Google, I installed that one, and then I installed again here Xschem. So I made it successful. So make sure that you don't have any error message here. All right, now we are going to go to step 3, installing the Magic VLSI layout tool. So go back to EDA tools. Check it. So Magic is here. Go inside Magic and then configure this one. Great, and then make. So the Magic VLSI is here. Then make. Oh, we have 2 errors here. See, sometimes we have some error. Let's check what's the error here. Error 1, error 2. It's saying failure to create symbolic link read line. File exists. Maybe this is because of I installed this one before and then I delete everything. And then this one, this is my second time installing every tools. Maybe some remaining files is already exist here. Let's continue. Hopefully this one. If this is your first time installing, maybe you don't have this issue. Okay, here I think it's installed. And then let's go back to EDA tools here. So Xschem and Magic is installed. Now let's install Ngspice. So Ngspice is for the simulation and making the netlist. Okay, now let's go to Ngspice directory. Okay, from here make directory release. This is basically coming from installing the Ngspice. So basically it's same as here. Now some steps, it's not exactly from same as there. Sometimes we have the error, so make directory release here inside Ngspice. Just to run this step by step. Okay, go to release and then right, then make to compile. Okay, no target is specified, no makefile font. Okay, let's try sudo make. Okay, I think I have make a mistake here. There's no need to be here option ADAMS. Sorry about that. So original is just autogen shell. To be honest, I really don't know what's going on here. So make directory release and then so before release we're going to just autogen shell and then go inside the release and then let's try this. Let's try configure. Unorganized enable ADMS. Okay, doesn't care. And then this time sudo make. Okay, this time works. So I believe you don't need this option here. And then here make it sudo make. Okay, compiled and then install. Okay, basically we installed Xschem for the schematic capture, Magic for the layout, and Ngspice for the simulation. Next, we are going to install the PDK Open PDK Sky130 nanometer. So now we are going to install the Open PDK. Go back to EDA tools. So this is the directory that we install every tools. We installed Xschem, Magic, and Ngspice. Now we are going to install the Open PDK 130 nanometer. So download the source from the GitHub. So go to and then go to Open PDKs, and then we're going to configure. Okay, compiling. We have two errors. So it basically says no module name this called these tutorials is found. And also another error, no module named setup tools. Okay, so we're going to search on Google. So just search Linux setup tools install. There's not much on the Ubuntu. Okay, how to install Python setup tools properly. I think it's related. I think it's related to Python. Uh, it will work if we install Python. So here, see this one. Get install Python and the setup tools. Copy that. I don't know. Oh, copied several times. first install the setup tools. Yeah, it depends on what's the Python version. So I remember this one is Python version of 3. And setup tools. Let's see. Okay, now it's properly installed. Okay, now go back to. Now let's compile it again. Okay, compiling took a little bit long time, but this time without error. So make sure that you install Python setup tools, and also make sure that which version. Usually it's Python 3. And then we're going to install. All right, and then go back to the tools. Here, basically one last step. This one basically integrating the PDK with the layout tool. Okay. We done pretty much everything. Integrate here. So we installed Ngspice. We installed the PDK. We installed the PDK or the Open PDK. But one here important. This one I believe it's a little bit later when we start to simulate. When the simulation directory is created. Right now we don't have that simulation directory. I believe when we simulate it, it will create it automatically, and then we are going to set this parameter. So now, final step is to test and open Sky130 nanometer example circuits. Let's have a look. So it basically make a directory, the test, and then go inside here and then invoke the tool Xschem. So as I said before, make sure that separate that EDA tools. So I have done a lot of cadence design tools, and I have worked in the company. In the company, there's a very strict rules about like managing the files. So it's good for the company, and it's also good for the employees. Like naming projects and the versions of the projects, and there are so many. I mean, managing files and the directory is one big job. So we installed this OpenPDK, Xschem, Magic, and Ngspice inside these EDA tools. So now we are going to this home directory. So here, I also make it here. I also first test. So organizing project files makes life easier. So we are going to make projects directory here. And go inside projects. So if print working directory, so inside projects, so we have so many projects, like in the future projects, right? We are going to first, I'm going to test the inverter using this Sky130 nanometer PDK. But right now we are just look at the example circuits. So here again we make another directory to test these example circuits. Go inside test, and then basically copying this, copy this PDK, the source scheme to inside here. Now if you look at here, so Xschem file is here. Now we invoke the Xschem. Now Xschem is opened. This is exactly same as this example files. I think this is the great way to start with example circuits. And I've looked at, I tried before this schematic capture, pretty much basically same as the cadence tool. So F is a zoom fit, and here we have all the example circuits. So this is hierarchy. If you go inside, so just click it and the E. This is same as cadence. If go back to the higher level, Control E, etc. Click it, E to go inside, and then Control E to go back. And then here we have so many tutorials here. I think it's very good links. For example, the device details, the PDK. Basically, it says Control and click it. It will open the PDK. Open that link, and inside here all the device information here. So I think it's a good way to check all the information here when we designing the projects using this process. I think I'm going to make a video later about all these example circuits. I think it's good for myself to familiarize with the tool, plus also familiarize myself with the basic IC design. So we have this band gap. We have these band gap circuits. So we have this BJT, this op-amp, making these 2 points the same, and then we have generating PTAT on this register, right? So I think I'm going to look at every circuit, example circuits here. It's a very good way to start here. This is analog, and then we have also digital circuits here. Let's look at it, what we have. Oh, okay, we have this 7-segment display, digital circuits. It's a great way to learn. And all the devices available in this process, right? So thanks for watching.